Hello everyone. Today I'm going to be talking about environmental mold contamination in homes. My objective for this presentation is to have you all coming away from this being able to describe common molds and their exposure source, explain the pathways from exposure to disease, understand the global occurrence of this environmental issue once I demonstrate it, and be able to break down the financial cost and disease burden. So, the representative figures chosen to accomplish this will first be on common household molds, then a figure on linking dampness with health, followed by a worldwide reported indoor dampness, the health costs of mold exposure, and trends in asthma in the US, with a brief summary and a few references. So, to begin, biological air pollutants are found to some degree in every home, school, and workplace. Some sources include air in human occupants who shed viruses and bacteria, animal occupants that shed allergens, and indoor surfaces and water reservoirs where fungi and bacteria can grow, such as humidifiers. A number of factors allow biological agents to grow and be released into the air. Especially important is high relative humidity, which encourages house dust mite populations to increase and allows fungal growth on damp surfaces. Contamination can be caused by flooding, continually damp carpet when carpet is installed on poorly ventilated concrete floors, inadequate exhaust of bathrooms, or kitchen generated moisture. Appliances such as humidifiers or dehumidifiers, as well as air conditioners, support the growth of bacteria and fungi. Components of heating, ventilating, and air conditioning systems, such as air intake sites, may increase microbial growth. Most fungi are active over a broad temperature range. However, high moisture and relative humidity are required for optimal growth. The lowest relative humidity supporting mold growth is approximately 75%. Increasing temperature and nutritional status can lead to lower moisture requirements. Surfaces that are soiled or have susceptible paint or paper do not need to be as damp for mold to still develop. Fungi also need nutrients, which may include carbohydrates, proteins, and lipids. Sources are diverse and plentiful, ranging from plant or animal matter in the house, dust to surface and construction materials, cooking oils, paint and glue, wood, store food products, and books or other paper products. Fungi may even grow on inert materials such as ceramic tiles and can obtain sufficient nutrients from dust particles and soluble components of water. So, water remains the most critical factor in indoor fungal growth and is more commonly seen in damp houses. So, certain locations of biological pollutants that may be found in the home include dirty air conditioners, dirty humidifiers and or dehumidifiers, bathrooms without vents or windows, kitchens as well, dirty refrigerator drip pans, laundry rooms with unvented dryers, unventilated attics, carpets on damp basement floors, bedding, closets on an outside wall, dirty heating air conditioning systems, dogs or cats, and water damage around windows, the roof, or basement. This chart shows a collective of percentages of commonly found molds in the home. Each slice shows the volume and rate that they were found within the sample population. As you can see, the three found most were Eulocladium, penicillin, and Cladosporium. Cladosporium is typically a black or green pepper-like substance that grows on the back of toilets, painted surfaces, and fiberglass air ducts. While this mold is non-toxic to humans, it can trigger common allergy symptoms such as red and watery eyes, rashes, and a sore throat. Aspergillus is another fairly common allergenic mold that is typically found on foods and in home air conditioning systems. Mold that appears to be orange or red in color is typically found outdoors given its nature to thrive on decaying plants or moist wood. This type of mold is also harmless and should only be removed for aesthetic purposes. White mold is not technically a type of mold, but can indicate the mold is only in the early stages of growth and can easily be treated. One of the more harmful and toxic molds, though, is Stachybotrys chartarum, more commonly known as black mold. Harmful molds can be any of the following classifications: allergenic, pathogenic, or toxigenic. And these may cause three types of human disease: hypersensitivity diseases, or specific activation of the immune system; infection, where pathogens invade human tissues; and toxicosis, where biologically produced chemical toxins cause direct toxic effects. In addition, exposure to conditions conducive to biological contamination, such as dampness, water damage, has been related to nonspecific upper and lower respiratory symptoms. Which brings me to the potential pathways of dampness leading to health outcomes. There are many different sources in which we use and expose our living conditions to water, such as plumbing or cooking, cleaning, showering, bathing. This may then lead to dampness found within either surfaces or structures of our home. Without a proper removal of water degradation, biological growth may begin to occur. This leads to either chemical or biological exposure, and through different immunological stimulation or autoimmunity, symptoms then begin to arise. Top symptoms linked to dampness or mold can be attributed to coughing, wheezing, dyspnea, asthma attacks, irritation, and itching, which then can finally lead to a diagnosis of either infection, asthma, or allergies. This global map looked at a review of countries and the reported household dampness, so therefore possible mold exposure. Canada reported that at least 20% of buildings had one or more signs of dampness. Several studies conducted in the US estimated the prevalence of dampness or mold in houses to be approximately 50%. A study in Estonia, Norway, and Sweden of indoor dampness had the lowest prevalence in Sweden at 12%, 18% in Norway, and the highest prevalence in Tartu, Estonia at 31%. Dampness was defined on the basis of self-reported indicators such as water leakage or damage, bubbles or discoloration of floor coverings, and visible mold growth indoors on walls, floors, or ceilings. Although there is less data available for low-income countries, several studies did suggest that indoor dampness is also common in other areas of the world. A study in rural Taiwan showed 12% of residents considering their dwelling to be damp, 30% reported in the presence of visible mold inside the house in the past year, while 60% reported at least one of these occurrences. In Japan, there were a newly built housing area where residents of all houses reported condensation on window panes or walls at around 41%. 13% of adults living in Nikkel in the Arctic area of the northern Russian territory reported dampness in their homes. In Singapore, the prevalence of dampness was 5% within their bedrooms. And about 11% of residents in cities in China, such as Beijing and Hong Kong Special Administrative Region, reported mold on the ceilings and walls. With increasing scientific understanding of the problems represented by moisture and dampness, along with the recognition of the widespread nature of these problems, all countries must pay proper attention to how the quality of construction affects these problems. As construction practices vary among countries, it is difficult to create guidelines that are applicable in all regions. Nevertheless, many problems have the same origin and their solutions are thus similar in principle. This graph looks specifically at financial costs of top respiratory issues in the US in 2016. The annual costs attributed to dampness and mold are estimated to be about $3.7 billion for allergic rhinitis, $1.9 billion for acute bronchitis, $15.1 billion on average for asthma morbidity, and $1.7 billion for asthma mortality, an issue that definitely has the potential to be addressed and reduced. Specifically looking at asthma, we are witnessing an increasing trend in prevalence. Knowing that mold can be a contributor and exacerbator to these trends means that prevention is key to avoiding further harm to any occupant's health. So, the common denominator of microbial growth and these health outcomes is an undesired moisture behavior. The reasons for the presence of mold and mites are the same all over the world, but the methods of control may differ. Water intrusion, dampness, and moisture related phenomena are not only harmful to occupants' health, but there's also a serious risk to building structures. In addition to risk of rotting wooden structures and microbial growth, building materials can also be degraded by chemical processes induced by moisture. Moisture control, including ventilation, is the main method for containing mold and mites. The problems of building moisture and dampness, microbial contamination, repair and control practices vary by climate zone. Regardless of the climate, however, the prevention and control of moisture and the subsequent effects should be addressed in the early phases of building constructions and by sustained maintenance. Methods should further be developed to allow calculation of fungal spore transport through building assemblies. It is evident that a sufficient flow of outdoor air for ventilation is necessary to remove indoor generated pollutants and moisture from indoor air, or to dilute their concentrations to acceptable levels for occupants' health and comfort, and to maintain building integrity. Ventilation can be provided by either natural or mechanical means, but both need careful implementation to avoid malfunctioning. Failures in ventilation may lead to serious health problems and damage to building construction. There are going to be biological pollutants found in our homes, as they are impossible to eradicate 100%. However, in order to increase prevention, it will require upkeep, maintenance, and proper structural assemblage. This may include everything from cleaning surfaces that come into contact with water or buildings to improve upon their structural designs for ventilation based on the appropriate climate. Either way, addressing this issue is essential to lowering exposure to mold and therefore the risk associated with it being linked to respiratory problems. Thank you very much for your time. This concludes the presentation on environmental mold contamination in homes.